This is a Model A Comptometer. This is from 1904. I think there were only about 20 or 30 of these known to exist anymore. There were only a couple thousand made. When I got this one, it was completely jammed. I've spent the past couple of days trying to get it working again. I'd say it's about 95% working now. See, when I enter keys, it does in fact do something. The problems that I still have are it does occasionally get stuck, usually while clearing. Clearing works by setting all the digits to 9 and then adding 1 to this column and then having it carry all the way across the machine. And carrying all the way across the machine sometimes sticks. It'll carry column to column fine. So when I add 9 in this column, it carries over every time. See, now it got stuck there. See, this still sticks sometimes. That got stuck. So like I said, about 95% working. Clearing, we'll put the handle on the side here. I can get this on. It's a very loud clearing mechanism. So it cleared all the way across to here and then got stuck. See, this keeps sticking. Oh no, that one got stuck. And this column, for some reason, the little carry thing in here gets stuck like that sometimes. Got stuck again. Anyway, like I said, 95% working. You can use it for math. See, these still didn't clear. There we go. Good enough. Now there are plenty of videos that describe how to do multiplication, division, whatever on here. Just for a quick multiplication to show you that it does in fact get correct results. We'll do 25 times 25. And 625 is the correct answer. Of course, it would help if I actually had that in view. This one displays the results on top of the register, so you see 625. We can clear that and try again. So I think what happens is this one, see, ripple carries across here, and then this one doesn't move far enough to drive that. It got across there, and those are all 9, so the carry got lost in there. So like I said, 95% working now. These are the carry inhibit levers. So if I hold this in, it won't carry. To that column, and then when I release it, it does carry. So, I'll just give you a little description of how this mechanism works. I think there are also videos on that, but I think there's a CAD video, like an animated CAD, showing it. Well, I like to show the actual real mechanism. And by the way, it is fine to have the machine sitting out of its case like this. It has these things that it rests on, which it rests on these when it's in the box anyway. So if you look at the bottom here, each of the key stems, which you can see in this side, those are the key stems all in there. So when I press a key, it wiggles. Each of the key stems comes out the bottom into these things, and these things just apply tension to them. So you see it's loose here. I push it down that far, and when I push it down further, it actually drives the mechanism. You can see this. I push it down a certain length, and I push it down further, it actually drives the mechanism. So these just put tension on the bottom of the key to hold it up to where they want it to be, so that they don't just sit on the mechanism all the time. I assume that's just for appearance sake. If you had all the keys just sitting on the mechanism, they wouldn't be in this nice linear column here. See, the one goes down pretty far before it hits the mechanism, but the 9 hardly goes down at all. So if they didn't have that on there, I can show this. These would be, maybe that drove it. It's a much steeper step that way. So I think that's just for appearance to have them in this nice even row. Anyway, the way that the mechanism actually works is, see this bar here? This bar, when seen from the front, is what has these, so it has these teeth on it. So when I push down on that bar, you see the teeth move. So the keys have little tabs on the side which push down on that bar a set distance, and then when you release the key, the bar comes back up and drives the digit wheel. If I can show this from the side. So this is that bar here, and you watch, when I push down on the key, it pushes that bar down. When I release the key, the bar comes back up and drives the mechanism. I notice this thing here, this is a stop. There's actually 2 of them. If I move this out of the way, you can see there's one behind it right there. And this little flattened half rod here is what this pin is. And the way that those work is, you see how it has this little tooth thing in here? So when I push down on the key, that comes out to stop the bar, so you don't overshoot and add too many each time. And that was another problem when I got this. Somehow, just in the first column here, these had gotten bent. So when you push the key down, the stop didn't come out far enough to stop this from adding. So every time you push, say, the 4 key, it actually added 6 because it didn't stop in the right spot. But now when I push 4, that comes out right nice into the mechanism and stops it. And I can reliably add 4 and get an accurate result. And these stops are driven by these rods in here. So it's a little bit sticky there maybe. Notice when I push down on the 4 key, it pushes down so far, and then this bar will come down. See that? And push the stop out to stop it. And it's kind of interesting. All the odd keys use this stop, or all the even keys rather use this stop, and all the odd keys use that one. So if I push a 2, it uses that. If I push a 4, it uses that. 6 uses that. However, 1, 3, 5, 7, and so on all use the one on the other side. Thought that was kind of interesting. Now for clearing, if I can get this in frame. This is the clearing handle here, and you notice that it has this lumpy thing on it. And the way that this works is when you first pull on the handle, notice this bar moves. This bar pulls on these things, and this has a shaft that goes all the way across the bottom of the machine. And see, notice how it pushes these out. On the end of these things is a little finger, and that finger grabs on a stop on each of the wheels so that the wheel can't rotate past 9. So how it actually works is this thing rides on here, and first the fingers come out. If I can show this appropriately. First the fingers come out, and then this thing rides across here, and this pushes down on the adding bar. And what it does is, it adds, every time a lump goes by, it adds 1 to the wheel in front. So this will keep adding 1, 1, 1, 1, and so on, until this, with the finger on the end, grabs the wheel and stops it. And it'll stop it at 9, and then when this gets to the very end, it'll add 1 to the last column, and since all the columns should be 9 at that point, it'll carry right across the machine and clear it all out to 0. Kind of an interesting way of doing it, but... And that's what's so loud, is all these, because each column has one of these things, so all these ratchets going over these little drums here is what makes it so loud to clear it. In the model, this is the Model A. The Model B used the same mechanism, but it had a different dial display. The Model C changed to a lighter mechanism. I actually have a Model C here, I'll show you in a minute the sound difference. The last thing I'll talk about is the carry mechanism in the front here. So that's what these wheels down here, these big gears, are the carry mechanism. And the way that it works is, all the way down inside there is a little, it's a little shaft, and it has 2 things that stick out on either side with a spring on it. And as you keep adding, this wheel turns, but that other shaft that rides on top of it is locked. And this wheel turning just builds up tension on the spring. And when this gets to 9, this little thing here gets hit by a knob. I can show this appropriately. This little thing here, you can see it better on this column. See how that moves back and forth? The little wheel down in there rests against a hook on the back of this. And then there's a set of knobs on this wheel. And when the knob lifts this up, that releases the little flywheel down in there, which spins around and hits on this thing. It releases this, and then it hits on this, which, as you can see right there, oh, it didn't come all the way back up. You can see right there, when I pushed this down, it added 1 to this column. Let me see if I can show that again. So this gets released, this gets pushed in, and you can see that it added 1 to this column. So that's how the carry works. This thing will release the little flywheel down in there, which will spin around, knock this open, push this down to add 1, and then go back into position for the next time. Now, I'm not quite sure why they did it this way, but these wheels spin around twice for every rotation of these wheels. So there's 2 pins on here across from each other that activate the carry for each half turn of the wheel, which is a full turn of this wheel. So I have a 6 on here now. If I add a 4, it should carry. You can see that it did. So watch this thing. This thing goes down every time it carries. You can see right here, that's the little peg little peg that lifts this up at the appropriate time. Also, when I got, the reason why these springs look so, these ones here like this, especially that one there, and that one there, most of these were broken, and I kind of stretched them out to reattach them. I should probably replace them because they don't have the right tension on them anymore. I mean, this has more tension on it than the original would have, and that could be part of the reason why it jams so much. Just a little piece of dirt in there. The reason why this one is so dirty is because it should have a glass cover on the register, which of course is broken. I only found a shard of it in the bottom of the case. So with that broken, all the dirt and everything got in the mechanism and rust and messed it all up. Now the dial cover is kind of interesting. So you see how it has a frosted, I'm going to focus on that, frosted piece part here and clear parts here and here. So the clear parts are supposed to go on top of the numbers like that, so you can see the numbers through the glass, and the frosted part covers up the mechanism. This was just sitting in the bottom of the case. So for now I'm gonna leave this as is. I'll have to see if I can find appropriate springs, and once I find the appropriate springs, I'll put them on and see if it still jams and what I can do about that. But like I said, 95% working, which is much better than it was when I got it. When I got it, all of these rods were all way down, jammed in, nothing was moving, so I had to free everything up. So I'll put this back in the case and show you it next to a Model C. Just to give you an idea, this is what the bottom of the case looks like. So all this dirt in the front here is what was underneath the register. So all this dirt was going in through the register to sit down here in the bottom of the case, which is why everything was so messed up. Okay, so I got this all back together here. By the way, these are our decimal pointers right here. You just set wherever you want your decimal point. Like if you're doing dollars and cents, you'd set this one so you know that this is where the decimal pointer is. This is the Model C. This is actually a Model C Lite. All that means is that they have a lighter key press than the Model C. And I also changed to these celluloid key taps instead of these older style composition ones. So this one is pretty stiff. Actually, they're pretty close, not that much difference. Difference though is obviously in the case. This has a metal, they call this a lazy S because it's kind of like an S curve on the side going down. And then it just has little circle windows for the digits. You can see that. And here they have yellow for the black columns and white for the white columns. So I had to repaint that one. These are plastic with just colored plastic fill in for the numbers, and some of the plastic fill for the numbers fell out, so I had to repaint some of them. And the decimal pointer on these are just these little things that fold out. Oh, and also, I think I mentioned these are the carry inhibit things to prevent carry over to the next column for subtraction. On this one, it's just these little things, you just push these up to inhibit the carry. So, let's see the difference in sound. So this is the Model C Lite. This is the Model A. So clearly this is significantly louder than that one. I don't think the glass here would do much to dampen that. It looked pretty cool though. You have the glass on there. I have to see if I can get a piece made. I have a sample at least, so I know what to get. But this is our Model A Comptometer. 95% working. So I hope you enjoyed this video. actually cleared over, almost. There you go. So, our A Comptometer, 95% working. I hope you enjoyed this video, and thank you for watching.